Very, very small fascicle of cardiac myofibers or muscle cells here. Looks like 1, 2, 3 of them here. What's this gray in between the cardiac cells? Endomysium connective tissue. Endomysium connective tissue here. And the cross-sectional view reveals a couple of things. A central nucleus, deep nucleus in there, and we can see myofibrils. So every bump, every circle, and there's one myofibril in cross-section. So longitudinal view, you can see every ridge, every upraised ridge is a myofibril running through the entire length of the cardiac muscle cell. Capillary running through endomysium for aerobic respiration, delivering oxygen to, removing CO2 from the respiring muscle cells. Longitudinal view, single nucleus. Cross-sectional view, central nucleus, deep nucleus, so mononucleated. Longitudinal view also reveals striations. The cross-sectional view does not ever reveal striations. Even if it is a striated cell, the cross-section will not reveal them. So you will only see striations in a longitudinal view. So this is one cardiac muscle cell. It ends in an intercalated disc here on the left, and it ends in an intercalated disc here on the right. So this is one cardiac muscle cell. That's another. That's the neighbor. It's a separate cell. But the linkage, the gap junction linkages here, make them act, make them function as if they are one cell. Because if we trigger an potential here, it would spread through to the next cell and trigger contraction of that cell also. We contract as a group. Functional syncytium. We talked about it earlier. What else? That's the nucleus of one of the endomysium connective tissue cells. That's all. This we do need to talk about. I spent a fair amount of time in lecture class today talking about this thing. I think that is a postsynaptic autonomic neuron called to the sarcolemma. This is the sarcolemma of the cardiac muscle cell. So that is either a postsynaptic sympathetic, which would secrete norepinephrine when it develops an potential, or a postsynaptic parasympathetic neuron which would secrete ACH from these axon terminals. Let's see, this view here also shows a branched cardiac muscle cell right there. This is a really poor view. That makes no sense to me why that's so huge. It makes no sense at all to me. But that's why they're not saying anything, but they're trying to ignore it. Don't look away, avert your gaze. Any questions? Skeletal myofibers here. And so sarcolemma and striations, multiple nuclei. So striations and multiple nuclei, guaranteed, hands down, skeletal muscle cell. And the cross-sectional view reveals that they're very, very shallow. They're just under the sarcolemma. So what's wrong with that view? What's wrong with that view? That one's okay. I've got no problem with that nucleus here on the edge. Two in the middle, too deep. They shouldn't be there. We should get some nail polish and cover them up. Actually, no, I like them there, so I can say they got that wrong. I can wag my finger at the wrong. Another thing they got wrong, I'll get to in a moment. So we have the endomysium connective tissue surrounding individual cells, and running in between individual cells, and yes, we see the nuclei of the connective tissue cells. Capillaries running through the endomysium here, and here we have one axon one axon collateral of a somatic efferent motor neuron going to this skeletal muscle cell, and another axon collateral with the very, very same neuron going to this skeletal muscle cell. So each skeletal muscle cell receives one axon collateral of a somatic motor neuron. There's a one-to-one relationship between axon collateral and muscle cell when it comes to skeletal muscle. So, sarcolemma, this dark brown portion of the sarcolemma is the motor endpoint, this ripple region we talked about with regard to the first model. That's where all of the nicotinic cholinergic receptors are in the membrane of the motor end plate. And so fortunately, we've got all the axon terminals containing ACH hovering right over the motor end plate. Action potential, secretion of ACH directly onto the nicotinic receptors, the cholinergic receptors of the motor end plate. The rest, so we would get a depolarizing low potential called an end plate potential spreading out to the surrounding sarcolemma, which does not have the nicotinic cholinergic receptors, but the rest of the sarcolemma does have voltage-gated ion channels for the generation of an action potential. So if there's enough ACH being secreted, another action potential coming in, more ACH, another action potential, more ACH, in a big depolarized summation, depolarized low potentials here and here, opening up voltage-gated channels, bang, bang, simultaneous action potential spreading in both directions along the sarcolemma away from the motor. And then into the cell along these transverse tubules, which are continuations of the sarcolemma with voltage-gated ion channels. Oh, the other error, this is accurate. We have the axon collateral leading to the outer surface of the motor end plate. Here they show it going under the sarcolemma. It does not burrow under the cell membrane. That's just ridiculous. Okay? Cell fascicle of smooth muscle cells. Spindle shape, tapers to a point at both ends. Longitudinal view, no right angle bands, no striations. Single nucleus, deep nucleus, not shallow. Endomysium, connect tissue in between and around individual muscle cells. The capillary looks really big here because this capillary here is the same as that capillary here. But it looks so much bigger because these are much smaller cells. These are big skeletal muscle cells. These are little smooth muscle cells. So try and keep the scale appropriate to this. Now, what else? This would be a postsynaptic autonomic neuron. Could be sympathetic, could be parasympathetic, no real way to tell on this model. And as I mentioned in the lecture class today, these smooth muscle cells may only be innervated by one division or the other of the autonomic nervous system. Or there may be the other type, the other division, postsynaptic neuron coming in from another direction to the cell. But again, we can't tell. We can say with certainty this is a postsynaptic autonomic neuron. That's as far as we can go with it.